books and other computers set up.
All right, so we're going to have to take our first quiz today. I've already put it out there. It opens up at 1:30. So at 1:30, I'm going to stop talking, and you guys are going to take your quiz. You've got technically until like 1:55 to get it in. So like a 5-minute kind of cushion to turn it in. So get ready for that if you're not ready already. We're going to just continue writing SQL until the cows come home. So continue learning. I'll pick up, I guess, where we kind of left off last time. One thing that we didn't do, we were talking about doing like equations inside of the select portion of a select query, using different different fields inside of a table, and then doing some sort of mathematical operation to them. And that's kind of where we left off. In that same vein, I want to talk about string concatenation. So let me pick a table really quick. Sales order detail. What do we got inside of there? Sales order, tracking, order quantity, special unit price. That's not going to help me. What about product? Dot product. Let's see what's in there. We've got name. Okay, gotcha. This is what we'll do. So we're going to, first off, select everything from product. No. Yeah, production. Dot product. So here's all of our stuff. So let's say we're creating some sort of interface, and we need to take multiple pieces of information inside of this table and concatenate them together and make a new field. So we want the product ID. And then the next thing that we want is we want a concatenation between the name and the product number, and we want something to divide those two. So let's do name and then a colon and then a space and then the product number. For some reason, that combination of things means something to us. So in order to accomplish that, we're going to use the concatenation operator, which is just the plus sign, just like it is in most languages you guys have messed with. So it'll look something like this. So it's name, and then we're concatenate onto that a string of a colon and a space, and then we're going to concatenate onto that the product number. Yeah. Whoa. Hello. There it is. Product number. So product ID, this string, and then product number. So execute that. What? Oh, I highlighted it. Sorry. So this is what we get, right? Maybe? Yeah, there we resumed. Right, so product ID, and then adjustable race R dash whatever. Right, the concatenation works. So what if we wanted to name this column? How do we do that? Right, we put as at the end of this. As, and then I don't know what to name this. Name number. We'll name it that. Super awesome. Then I've got product ID and name number as information inside of here. So, as with the arithmetic that we did to the fields earlier last time, you can obviously concatenate whatever the heck you want to inside of here, right? You can put the concatenation operator before, after, in between. You can put as many attributes inside of there as you want to. You can put as many as many constant strings inside of the concatenation as you want to, wherever you want to. You guys cool with that? Okay, good. Try not to spend too much.
That's not going to cause, obviously it doesn't cause an issue, but like that.
Right, so if name was actually used in a context in which it was a keyword inside of SQL, then it would make a difference. But SQL Server is smart enough to recognize that you're not meaning name. But you are right. It's always good practice to encapsulate field names that are also share the name of, because, you know, what if there's a field name inside of a table called from, right? That's an issue. So that'll throw all kinds of errors. So if there's a field inside of a table that is a keyword, it's always good practice to encapsulate it in square brackets so that way the interpreter knows what you're talking about whenever you do it. Also, one thing I don't want you guys to think is that there's a lot of languages really popular, like Python and Visual Basic and you know, all the other languages in that same vein, where you know, spacing and indentation and stuff like that matters. In SQL, I know we've talked about, you know, space doesn't matter, but I mean, lines don't matter. You can break individual independent objects up inside of SQL just like you can Java or C# or something like that, just as long as, you know, you don't end in the middle of an operation or something like that. You can't, well, I don't know, sometimes you can, but just don't worry about spacing as much unless you start getting errors whenever you do it. All right. So what if we wanted to, oh, that's fun. So we talked about, let's say we want to order this thing by name number. How would we do that?
Order by how?
Name number, that new thing that I just created.
Order by name.
So you do order by name number. And I want you to notice something. When you alias something inside of SQL, it picks up on the IntelliSense picks up on the alias. So now name number is one of the things that'll come up. And if I launch this thing, then it'll order it by name number. And name number is obviously going to be some sort of string. And so by default, it's going to do an alphabetical ordering in ascending order. I mean, technically it's ascending because it's going through ASCII values, and they're really integers that it's sorting. So it is going in ascending order. Now you can change the order that the order by does. So by default it does it ascending, but you can do I can't remember.
I think it's C in there.
Yeah, I think the C is inside of there also. So yeah, that's descending. And there's also a keyword for ascending. So if you want to, if for some reason it's not sorting something ascending by default, you can just put the ascending keyword inside of there, and it's an abbreviation as well. So this is how you change the order of the order by. So watch this. Let's do another selection. Let's do something new. I'm trying to poke around inside of the database as much as I can to kind of introduce you guys to all these tables that are inside of here. So for every query, I'm probably going to choose a different table. So let's do select everything. There it is. from production.product model. Let's see what's in that table. Not much information is inside of there. Okay, I guess this would be a good activity to talk about null again and what you can do with null. So null is, we said this before, is an actual value that you can compare against. It's a keyword inside of SQL, just like it is a keyword inside of Java or C# or C or a lot of programming languages. Null means something different than empty. If we wanted to do something like go grab all of the products inside of here where a catalog description existed, how do we do that? What would my where clause look like?
Catalog, I guess, whatever you say, catalog what?
Catalog exists where there is a catalog description.
Where catalog is not null?
Yeah, there you go. Where catalog description, and here it is. I don't think we did. Maybe we did. Is not null, right? So is an independent clause. Not is an independent clause, and null is an independent clause as well. So is can be used by itself. Not can be used by itself. They can also be used in conjunction. Is not, and null is an independent clause as well. So if I launch that, then I would expect all of my values inside of here to have something, right? And these are links to XML descriptions, right? So if I click on it, it'll open up that XML that's inside of there, and you can see the XML schema of that particular, I don't know which one I clicked, Mountain 500, whatever that means. But this is the data that they would use to insert information into a catalog that they were printing, right? So your job would be to go out and get the catalog description and then to interpret the XML and then insert it inside the catalog after the interpretation is done. And I mean, obviously the catalog, whatever catalog means, right? Whether it means a physical catalog that someone gets, or maybe it means something different. Maybe it's a stocking thing, not Christmas stocking, but like shelf stocking thing, an inventory thing, I guess I should have said. So obviously there aren't many products inside of here that had this description. So I don't know. You'd have to look and see exactly what that means. But we can do that kind of thing. So if we wanted all the ones that didn't have a catalog description, then we would look for is null, right? Now all of the catalog descriptions are null. So there's far more that don't have a catalog description than do. And again, you can peek at the number of rows that you get back. Forward some more. Okay, so always glance down at that row count down here at the bottom to see what you're getting, and that it meshes with whatever it is you're expecting, right? So what I mean by that is if I execute this entire thing and I look, there's 128 rows, and the ones that are not null are 122. So I would expect the ones that are not null to be 6, right? Otherwise, I'm missing something. So if I put not back in here and I execute it, I should get 6, which I did. So it's painfully obvious in this example, but whenever we get to where we're, linking multiple tables together and pulling individual pieces out of each one of those tables and putting them together, it's always a good idea to get rid of all the condition clauses inside of there and see what your base is, and then especially if you're having trouble getting the ones that you want, and then slowly integrating in each one of the condition clauses so that you can see how it affects the original source, the original data that was inside of there. All right, let's talk about, now where's something like this going to exist? Okay, let's go into anything with a history. So we messed with pay history before. Let's do that one. Select everything from human resources dot employee pay history. Let's look at that really quick. Okay, so let me find an instance. Okay, right, so 4, right? So whoever employee number 4 is has had quite a career, actually. They've done really well. So they started out at $8 an hour, and now they're at $29 an hour. So they got promoted like a boss, right? So they've done good. But let's say I just wanted to pull, there we go. Let's say I just wanted to pull the business entity ID and the pay frequency. And those are the only 2 things that I wanted to pull. So I do business entity ID, pay frequency, and execute that again. And now, when I get results, I get multiple rows, multiple tuples inside of my results that are exactly the same. This happens all the time, right? So when you're just pulling bits and pieces of information, let's say, you know what? This is even better. So for whatever reason, let's say I want to use this table to pull business entity ID, right? I want a list of business entity IDs that exist inside of this employee pay history table for whatever reason. It's just what I want. People said, I want it, and you're the developer, and you have to do it. So let's do it. So get rid of this. Pull this stuff. I hate you. Do this. Right, so when I do that, I get every single business entity ID where that particular ID has received some sort of pay change at some point. It's duplicated, right? That's crazy. So how would I figure out all of the IDs that have more than one value inside of there? Have we talked about count yet? Let's talk about count. So there is another neat little method or keyword that you can use inside of here called count, right? And count allows you to do something like this. Business entity ID. And then let's execute that and see what it looks like. Invalid Y. Oh, because I didn't group it. We haven't talked about group by. I don't want to talk about count yet. Because I don't want to talk about group by. So let's go back and execute this thing again. There we go. So if you wanted to get a list of business entity IDs that were inside of here without having to deal with duplicates, right? So right now the only option we have is suck it up into a program, iterate through all of the objects, get rid of the duplicates, and then reform another whatever is holding it, and then go through that, and you'll have individual values inside of there. So in SQL, there's a neat little keyword that you can use right after select that will tell you to only select non-duplicate values. So if there's a duplicate, ignore it. Just give me the first value from it, because the rest of them really don't matter. That is, distinct, right? So distinct, whenever I launch that, and you look, I've got 316 rows in that execution before I did distinct. And then when I launch it again, I got 300 or 290. So we got rid of 26 rows inside of that set. And you can see that 4 only appears one time inside of there. So distinct becomes extremely important whenever you are pulling data from one or more tables where the subset of attributes that you're pulling, because obviously every table inside of this database is going to have a primary key, and there is no completely duplicated information inside of any of the tables, any of the relations, right? That breaks all convention of relational databases. You can't have it. But whenever you are projecting that information into a set that you're going to use, there can be all kinds of duplicate information inside of it, right? Tables hold subsets of attribute that are duplicated constantly. For example, this one, right? Business entity ID is replicated if you're just looking at that singular attribute, but if you look at the entire table, those rows are not. And so you're all the time going to get information that's duplicate, and sometimes you want it, and sometimes you don't, because sometimes you're trying to find the duplicates, and sometimes you're just trying to get to something like this, individual values that are inside of there. And so that's why you need to use distinct. And it must appear in this location, right after select. You guys okay with that? All right. Oh boy. They talk about union, intersect, and except. I guess let's talk about that. We need to.
It is 129, just to let you know.
It is 129.
Yeah, so go back to
You know what that means. That means it's quiz time. Oh yeah!